and it's something we kind of touched on a little tiny bit during class, so hopefully it won't be completely brand new and foreign. I picked this lesson on purpose because of the fact that we've already sort of touched on it. So, before we start, I want you to do these warm-ups. There's 3 problems there. I want you to find the derivative of them with respect to x, and your hint is to solve for y first and then take your derivative. So hit pause, work those out, and then I'll go over them once you come back from pause. Okay, so hopefully you have answers to the 3, or at least you have thought about them. You might have gotten stuck on one of them. So I'll do the first one for you guys. If we solve for y, we have 4x squared minus x, so that was the hint that I gave you. And then in order to get the derivative of that, we just do dy dx equals 8x minus 1, and that would be your answer to that question. For the second one, same idea. We're going to solve for y. So we'd have 7x cubed over x equals y, and if we take the derivative of that, we get dy dx equals, if you notice here that 7x cubed over x is just 7x squared, so we get 14x, so that would be your answer on that one. Now if you look at this third one, if I wanted to get this y alone, I could square both sides, but then how do I get this y alone? I could take the inverse sine of both sides, but you don't know the derivative for inverse sine, and it would be horrendously messy. And so hopefully when you got to this problem during the warm-up, you realized that there was an issue and that you can't solve for y. So in circumstances like these, when we cannot solve for y, or when it's not practical to solve for y, that's where we use implicit differentiation, which is today's lesson. So here are your 2 objectives. Pause it for a second and write them down, and then hit play when you're ready to continue. Okay, so hopefully you're done with that, and I just want to go over them real quick. So the first one is to identify when implicit differentiation is necessary, and we kind of already addressed that. When you have a situation where you can't solve for y, or where you could but it's really impractical, that's when implicit differentiation comes in. And then the next thing that we want to work on today is actually using implicit differentiation to get the derivative, to get this dy dx. Okay, so I will actually show you this one as an example in a little bit of how you would take the derivative of that. Okay, so the first question is, what is implicit differentiation? And as we go through, if you want to pause this video to take notes on this, then do that as necessary. I'll try to take a breath between things. So it's the same as regular differentiation. Honestly, it's not actually different at all, and I can show you in a little bit why it's not different. It just looks different, and so we teach it separately. Okay, the reason I kind of address this, that it's slightly different, is because we can't get the y to come out of the problem. We can't tease it out, and so we use implicit differentiation, but again, it's the same differentiation that you've already learned. It just looks more complicated. Okay, and so the only difference is, instead of getting the y alone, like we did on the first 2 warm-up examples, we have to leave it as part of the equation. And then once you're done, you end up solving for dy dx. And I didn't put this in this, but once you actually get the derivative, you usually have a y as part of the derivative, and I'll show you what that looks like in a little bit. Okay, so this again was our example of when we can't just solve for y and then take the derivative, when we have to use implicit differentiation first. Okay, so on the paper that you should have, and if you don't have it, hit pause and get a hold of it. I want you to look at example 1, and I want you to solve for y and then take the derivative of it. So pause here, do that, and then come back. Okay, so to solve for y, you should have identified that you can factor out a y here. So if you do that, you have an x left and a 1 left. Okay, and that's plus 1 equals x. And then I'm going to subtract the 1. And then the last thing that I do is divide by x plus 1. So y equals x minus 1 over x plus 1. And hopefully you guys were smarter about where you wrote that, because I wrote it all over my space that I have. So now the second question asks to take the derivative. So this is just going to be the quotient rule. So we have low is x plus 1, d high is just a 1, minus high is x minus 1, d low is 1, all over low. And you want to just go ahead and simplify this just because it's pretty easy to do it. When you multiply the ones in, nothing happens. So you essentially have x plus 1 minus x plus 1. This sign changed because it's subtracting. And then this is all over x plus 1 squared. So you should then see that these are going to cancel, these x's. And so you end up with 2 on top and x plus 1 squared in the denominator. Okay, so that's what you would write here if you hadn't written all over the line like I did. Okay, pause it if you need to, otherwise I'll go on. Alright, so example 2, same idea. Solve for y, and then once you have that, take the derivative. So go ahead and pause and take care of that and then come back. Okay, so to solve for y, I'm going to move that x squared over first. And then if you just take the square root, you have now solved for y. Okay, so now to do the derivative of that, we have 1/2 times 1 minus x squared to the negative 1/2, and then the derivative of the inside would be negative 2x. You can see that the 1/2 and the 2 would cancel, so go ahead and do that, and you end up with 1 minus x squared to the negative 1/2. There's this negative right there, and then the x at the end. Okay, so you should have hopefully gotten that. Okay, so now example 3, again, solve for y, and then find the derivative. Hit pause, and then when you're done, come back. Okay, so here you could try to put the y's together. So you get a 3xy minus y cubed equals x cubed, but now what? If you try to factor out a y, like we did in the first one, you still have this. That doesn't help us at all. And there's really not a lot you can do. You could try solving a quadratic or things like that, but it's not a practical situation. So we're going to put here, oops, let me erase this. I'm going to write not practical to solve for y. And for dy dx, since we weren't able to solve for y, you're going to say we need to use implicit differentiation. Okay, so go ahead and pause if you need to, and then otherwise I'm going on. Okay, so let's actually see it in action, and before I do this, I just want to show you a quick example, and then I'll tie it into this. So let's say we have something like 3x squared plus 2x equals y, and we want to take the derivative of that. So the power rule says we take that out front, and then that becomes to the 1, and then technically we would use the chain rule and take the derivative now of the x, right? So we have the derivative of x with respect to x. Technically you would write that. It's silly to write it because dx over dx is just 1. The derivative of x is 1. But I'm going to write it here to illustrate how that works. So for this one, the derivative would be 2, and then the chain rule says take the derivative of the x. So you'd have dx over dx. And then here, we're not just replacing it with dy dx. We're actually saying whatever the derivative of y is with respect to x, because we're differentiating everything. We took the derivative of everything, including this y. Okay? It just so happens that this is equal to all of that. So if you were to simplify this, the dx's would go away, and you'd get 6x plus 2 equals dy dx. So that's what we've been doing. The thing that you want to focus on is the way that we use this dy dx, and the fact that there is a dx dx. It's just that, you know, it's 1, so we don't write it. Okay, so pause if you need to. I'm going to erase this. Okay, so to take the derivative of this guy, we're going to do the same thing. We're going to take the derivative of everything. Y's and x's all. So the derivative of sine of y is cosine of y, and then we use the chain rule. So we take the derivative of the inside, which is just dy dx. Okay, let's go to the next term. Minus cosine x is going to change to plus sine x, and then if we take the derivative of the x, we get dx dx, but we're just not going to worry about that because it's just 1. And then for this last part, we're going to use the product rule because it's two things being multiplied together. So we have the first times the derivative of the second. So I took 1/2 y, the negative 1/2, and then I would take the derivative of the inside, which would be dy dx. So that's the first times the derivative of the second, plus the second times the derivative of the first. So be careful here. I have a dy dx because we took the derivative of the y part. Here I don't, because that part was being left alone and it was the x part that's being differentiated. Remember, after this 1 would be a dx dx, but we don't write it because it's just 1. So we can now simplify this. I'm going to put all the dy dx's on the same side. So we have cosine y dy dx minus x, or let me go ahead and write 1/2 x. So minus 1/2 xy to the negative 1/2 dy dx. So I just subtracted both sides to move this guy over there. And then I'm going to do the same thing, move the sign to that side. So we have y to the 1/2 minus sine x. It's okay that this y stays here with the x. Okay. So over on this side, I'm going to factor out the dy dx's. And then what's left here is cosine y minus 1/2 xy to the negative 1/2. And that equals y to the 1/2 minus sine x. So of course the last step now is to divide by all of this mess right here. So we have cosine y minus 1/2 xy to the negative 1/2, and over here the same, cosine y minus 1/2 xy to the negative 1/2. Okay, so to review what we did, we took the derivative of everything, including the y's. When you take the derivative of something with a y and you're doing the chain rule, you have to remember to do the very last step, which is the y itself, and the derivative of y is dy dx. You will generally have y's on both sides of the equation, and that's okay. And then after that, you're just solving for dy dx, and then that's going to be your answer. Okay, so pause if you need to. Okay, so I want you guys now to do example 4, and you're going to do this 2 ways. I want you first to solve for y and then take the derivative, and then I want you to go back again to this original formula or function and solve for y using implicit differentiation and see if you get the same answer. See if you can simplify it to be the same. So go ahead and pause here and then come back when you're done. Okay, so to solve for y, we'd say y equals 1 over x, which is x to the negative 1, and then to take the derivative of that, you would get negative x to the negative 2. So that would be that way of doing it. If we do it with implicit differentiation, which is actually a little bit more challenging, admittedly, for this problem, we need to use the product rule. So we have x times the derivative of the second, which is just going to be dy dx, plus the second times the derivative of the first, which is just 1. And then that equals, on this side of the equation, the derivative of 1 is 0. So if we solve for dy dx, get negative y, negative y over x, right? I divided both sides by x. But you notice that that doesn't look like what I got here, okay? And so there's multiple ways of doing this, but essentially you want to look for something that you can substitute in. In this case, I happen to know that y is 1 over x, and so I'm going to substitute that in for y. So we have negative 1 over x all over x, which is negative 1 over x squared, which is negative 1x to the negative 2, which is exactly what we got earlier. Okay, now obviously you can't always substitute in for y. That worked here because we were able to solve for y, but the whole point of implicit differentiation is that you can't solve for y. So you want to look for other things. Find somewhere where it says y over x, and then you can substitute that in. You want to try to get rid of the y on this side. It's not always going to be possible, but you want to try. Okay, so what I want you guys to do now is this guided practice, and then I'm going to go over all 5 of them, and I'll give explanations for all of them. So if you want to go through one problem at a time with me, you try one and then you look over it with me, that's fine. If you're feeling pretty confident, go ahead and do all 5, and then you can just kind of skim through the rest of the video to make sure that you have it right. Once you finish this guided practice, then you'll do the classwork, which is another 10 problems. so try not to take too long doing this, okay? So go ahead and hit pause, do as many as you're going to start with, and then come back here when you're done and I'll explain them to make sure you understand them all. Okay, so this is problem number 1 in the guided practice. We see that it would be extremely challenging to solve for y, so we're just going to leave it the way it is and do implicit differentiation. Okay, so here we're going to have 10y, and then of course we take the derivative of y, which is dy dx. So that first term is done, plus cosine y, and then dy dx. Okay, equals x squared, which is just 2x, and then dx dx, which we're not worried about. Okay, so if we solve for dy dx, we have 10y plus cosine y equals 2x, and then we just divide. Y plus cosine y, and then our goal would be to attempt to substitute something in to get rid of the y's, but there's not really anything. We don't have a 10y anywhere besides here, and that doesn't help us. We don't have a cosine y floating around anywhere that we could use, so we're just kind of going to have to leave that one like that. Okay, so pause if you need to, or if you're ready, just continue on to number 2. Okay, notice this one, just to be real careful, that it's 2, so you're going to have to do the derivative twice. Okay, so for the first one we have 8x minus 4y dy dx equals 0, and I'm going to solve for dy dx. So dy dx times negative 4y equals negative 8x, and then we just divide. So we would get 2x over y. Okay, so now we want to do that again, take the derivative once again. So we have second derivative, and we're going to have to use the quotient rule now. So we have low d high minus high d low all over low low. Okay, so if we simplify that, we have 2y minus 2x dy dx over y squared. And you see we kind of have a mess. We can substitute some stuff in though. I'm going to rewrite this up here and clear off some space, I think. Squared. Let me clear some space off. Okay, notice as I'm deleting this, I'm leaving the dy dx that we had earlier. And I'll show you why in just a second. Okay, so this is awkward to have the second derivative contain the first derivative within it. So we could just simplify by substituting this in. So we'd end up with 2y minus 2x times 2x over y all over y squared. So I replaced the dy dx with this guy right here, and then we could simplify it just a tiny bit. We could say 2y minus 4x squared over y all over y. If you wanted to continue simplifying it, you could say 2y squared minus 4x squared over y, which gives you 2y squared minus 4x squared over y squared. Okay, so you can pause if you need to and do the next problem, or you can just continue on. Okay, so number 3, now we're finding it at a specific point, and this is something I'm going to start throwing more and more at you guys. You need to be able to do the basic algebra with this calculus stuff. So all we're doing is substituting x and y, but you have to find the derivative first. So we're going to take the implicit derivative of this. We get 3x squared plus 3y squared dy dx equals, and this is the product rule now, 3x times the derivative of y plus y times the derivative of x. Okay, so we need to solve for dy dx. I'm going to simplify a little bit. 3x squared plus 3y squared dy dx equals 3x dy dx plus 3y. And so I'm going to move all the dy dx's to the left and everything else to the right. So 3y squared dy dx minus 3x dy dx equals 3y minus 3x squared. Okay, and then we solve for dy dx. 3y squared minus 3x. Divide that on both sides. So our final answer, or not quite our final answer, but our temporary answer, is this 3y minus 3x squared over 3y squared minus 3x. So now all you want to do is take this point in and plug it in for x. So go here, and then take the other point and plug it in for the y's. Okay? And I don't have a calculator on me, so I'm not going to work it out, but you should be able to do that. Okay. Number 4, notice that it's the same thing as number 3. The only thing I flipped was that it's not dy dx, now it's dx dy. So same idea. Since we're taking now with derivative with respect to y, that needs to be reflected across the board. So we'd have 3x squared, and then it would be dx dy. So the same way that we were writing dy dx, we're doing dx dy here, because we're taking the derivative of the inside, which is x. Okay, and then here we have 3y squared. Nothing has to happen to that because that's what we're taking the derivative with respect to. And then we had product rule for the second part, and it's still going to be product rule. So the first times the derivative of the second is just 1, minus the second times the derivative of the first was dx dy. Okay, and so now we just want to distribute and solve for dx dy like we did last time. Okay, I'm going to distribute this 3 here. So we have 3x minus 3y dx dy. Move all the dx dy's to one side of the equation. Okay, that's done. And then we want to get those dx dy's factored out. So we end up with 3x squared plus 3y equals 3x minus 3y squared. And then when you simplify, you have 3x minus 3y squared over 3x squared plus 3y. Okay. And now for the last one, we are going to, again, use implicit differentiation for this one. So the derivative of sine is cosine, x squared, y squared. Now we need to take the derivative of the inside. So we have x squared times 2y dy dx plus y squared times 2x. Okay, and that equals x, which is the derivative would just be 1. Okay, so we could factor this guy out. He's the only dy dx that we really have to worry about. So what we want to do first is divide both sides by cosine x squared y squared. And I just typed that wrong. Give me a second. Okay. Okay, so we've gotten rid of that. Okay, now we could subtract this. So we have 1 over cosine x squared y squared minus y squared times 2x. And then the last thing she needs to do is divide. So dy dx equals that whole mess there. Okay? And again, you might be able to substitute some stuff in. In this case, no. There's not anything to substitute in to simplify. Okay, so you guys now have your classwork, which is on that same page that you've been working on. It's 10 problems, and you notice that at the bottom of the page, I want you to see that I've put all of the answers for these 10. So I want you to check your answers as you're going and just make sure that you're understanding it so that you don't end up going down the wrong path and have it be irreversible damage, okay? So just make sure you know exactly what's going on and you're getting all the correct answers.